Okay, so now we are going to cover parallel circuits. We're just going to recap what the formula is for finding resistance total in a series circuit. So series circuit was R1 plus R2 plus R3. Now on a parallel circuit, it is slightly different. And that is that it is 1 over R1 plus 1 over R2 plus 1 over R3. It's solved the same. Once you find resistance total, you can use Ohm's law. So in this particular circuit, we have 3 resistors, R1, R2, and R3, and we're going to have 1 over 100, which is all going to be over 1, plus resistance, or resistor number 2, which is R2, is 100 ohms, and resistor 3, 100 ohm. So our total is 33.3 ohms. And one rule of thumb you can use when you're finding resistance total in a series circuit, and that is that the resistance total, which is 33.3 ohms, will always be smaller than the greatest resistor in the circuit, which in this case is 100 ohms. And you can see that proves out it's less than 100 ohms. 33.3 ohms is our total. Now we can use Ohm's law now that we have the resistance total, which is that we want to solve for I, because that is the unknown. We have the two knowns, and that is voltage, 12, divided by 33.3, which is going to be 0.36 amps. And now again, we can check that out by assuming that we didn't know what the voltage is. We could solve for V, which would be I times R, which is 0.36 amps times 33.3, which equals 12 volts DC. So we checked it. We know that it works. We can interchange this algebraically. This formula can be interchanged algebraically. In the next video, we're going to discuss the characteristics of voltage and current when it comes to a series and parallel circuit.